Hey everyone, today we are going to distinguish between the two methods of limestone formation and a couple of other things. So period 2, you already got some of this, but period 4, you haven't gotten any of this. So just want to make sure that whatever I'm drawing you have on your page. So open up to notes pack page 24. All right, you should be on notes pack page 24. If everyone's not there, just pause the video, let everyone get there. All right, so period 2, we didn't write this down yesterday, but I just want to clarify that what we're drawing here is in fact the two methods of limestone formation. All right, we know we have chemical limestone and we have bioclastic or organic limestone, and we're going to go through how that actually occurs, okay? So remember that we have the sun, that is the driving energy behind the water cycle, all right? So we're going to focus on a body of water. So we're going to have our shoreline, and this is our ocean floor, and another shoreline, and this is our body of water, all right? And when the sun shines down onto this body of water, of course, what's going to happen? What process? Whenever we draw squiggly lines coming off of water, that is the process of evaporation. So this is the evaporation of H2O, the evaporation of water. So dissolved in this seawater is minerals that are soluble. So we have soluble minerals dissolved in seawater. And what are those soluble minerals? Well, there's calcium carbonate, there's NaCl, there's rock gypsum, any of the soluble minerals that are going to form crystalline sedimentary rocks. So, as we talked about yesterday, as the water evaporates, this solution can become saturated, all right? So the seawater becomes a saturated solution, meaning it can't hold any more dissolved minerals. Those dissolved minerals are gonna recrystallize, okay? So because this happened, because the seawater becomes a saturated solution, the minerals recrystallize. All right, so let's say you have this little crystal of calcium carbonate. Note I drew it like a rhombus. Okay, so this is so what happens is solid crystals form. And because solids are more dense than liquids, these crystals precipitate. So the crystals precipitate out of the seawater solution. All right? And as this happens, this limestone forms on the bottom of the shallow sea. And if you look in the ESRT, what is the symbol? What is the map symbol for limestone? Well, if we look in the ESRT, the map symbol for limestone is this brick pattern, kind of like subway tiles. And so the way that we do that is we just draw horizontal lines, and then we just make one set of vertical lines, and then the other set of vertical lines in between the first set. All right? So what we get down here, for example, is this crystalline, and we're working on the left-hand side of the page because the right-hand side of the page is going to be dedicated to the bioclastic limestone. Now here, this is around the time where we stopped in period 2. So this is crystalline limestone, all right? And crystalline limestone is formed as the seawater evaporates. And the solid mineral that was dissolved, whoops, not was, that was dissolved in the water recrystallizes, comma, precipitates to the bottom and accumulates into layers of limestone rock. Okay? So that is how crystalline limestone. So this is the crystalline, aka chemical, aka evaporite, aka precipitate version of limestone forms. There is dissolved CaCO3 in the water. As the seawater evaporates, chemical processes occur. It recrystallizes, sinks to the bottom, and you get these layers of limestone rock on the bottom of the seafloor. Now, the other way that this dissolved calcium carbonate can get out of the seawater is when sea creatures use it, they absorb it to build their shells. Now, we know from yesterday that there are these microscopic creatures that live in the water, and they're plants, so they undergo the process of photosynthesis. And these little tiny creatures are called forams, Forams. And that is short for foraminifera. Okay, they're a type of algae. They're a single-celled creature, and they build their exoskeletons. Now, this is what built the White Cliffs of Dover. Trillions and trillions of these. As they died, they sunk to the bottom and accumulated, all right? There's also creatures that live in the bottom on the seafloor. So you got coral. I know that's kind of a sad coral, but you got coral. You got scallops, right? So those pretty shells that have the scalloped edge. That's why a scalloped edge is called a scalloped edge. All right. You got scallops. You got clams. So it's kind of like a rounded triangle with the lines on it. You got lobsters, everything. So you got coral, scallops, clams, mussels, anything with an exoskeleton, anything with a hard shell, right? So these creatures have exoskeletons. And they absorb, what they do is they're filter feeders, right? So they take in the water, they take in the calcium carbonate, and they build their shells. Well, eventually these poor little things, they die, and their shells go to the bottom of the ocean floor. Okay, so that's another way that the dissolved calcium carbonate actually becomes a solid, all right? So the other method is the bioclastic or organic limestone. Okay, so shelled exoskeleton organisms absorb CaCO3 from the water to build their shells. When they die, they sink to the bottom, unless they're already there, right? The clams, the scallops, the coral, they're already on the bottom. They sink to the bottom, the seafloor, right? They get deposited. Accumulate. Get compacted and cemented together to form, whoops, that says foam, to form bioclastic limestone or organic limestone. Okay, so what are examples? We saw the coquina yesterday, that's 100% shells, right? Coquina. Chalk, like in the White Cliffs of Dover. So yes, when you're writing with chalk, you're writing with limestone on a chalkboard, okay? And we also saw the gray and the tan fossiliferous limestone, right? And anytime you have any kind of limestone, either crystalline limestone or bioclastic limestone, since they are made of the mineral calcite, what are they going to do? If you're not sure if it's limestone or not, what are you going to do? You're going to do the acid test, okay? And if it fizzes, you have some version of limestone, all right? So everyone should have all of these notes and diagrams down. If you didn't get all this, you can go back into the video and watch it yourself. And now you're going to do some work in your notes packs and BFRBs, okay? And your lab, actually. All right, have a good day, everyone. I'll see you tomorrow.